Hello. Okay, so let's start today class. Today we are going to discuss about the speed and torque characteristic of the DC series motor. Okay. We already in the previous class when the DC shunt motor. हेलो. इस आवाज आ रही है?
यस सर.
ओके. तो पिछले क्लास में हम लोग क्या डिस्कस कर रहे थे? डीसी शंट मोटर का कुछ न्यूमेरिकल प्रॉब्लम सॉल्व कर रहे थे. रीजनरेटिव ब्रेकिंग, डायनामिक ब्रेकिंग एंड प्लगिंग ब्रेकिंग पे उसको कंप्लीट किया. Just one numerical where we discuss about the regenerative braking, plugging braking, and dynamic braking of the DC shunt motor. Have you completed that one? ये हुआ. Okay. So in the previous class, we already tried the no load torque. That means T minus T0 equal to 745 minus 716.2. Okay. So no load torque, we just find out that means 29.7 Newton meter. For the regenerative braking, just we want to convert the revolution per minute speed in equation with the torque and supply voltage. That is, we already drive the relation between the speed and torque of the DC shunt motor. That is nothing but V by C plus torque into R by C square. C is your constant. Okay. So just put here the value of omega. We already drive how much? That is 62.83 radian. So just put here the 62.83 radian in place of omega. And just find convert in the revolution per minute. So that is nothing but 650 RPM. Okay. I think just first of all share the screen. Okay. Let's start here. Yeah, I'll do this one. Just we will consider this problem. This equation we want to use here. That means V equal omega equal to V by K phi plus RTV by K torque into K phi square. This problem. Okay. So this is the relation in the speed and torque, and we just consider this problem. Okay. So just and here that means armature current, that is IL equal to II, my line current, minus IF. Okay, so this is your armature current that you can be represented as the IA. Okay, that is more frequently we represent the armature resistance by IA. So 100 minus 2.5, that means 97.5 ampere. Okay, and omega, that is angular velocity in radian per second, that is given in the revolution per minute in RPM. So just convert in the radian per second, that means 2 pi by 60 into n, 2 pi n by 60. Okay, so just put here the value of 2 pi into 600 by 60, that is equal to 62.83 radian per second. Okay. So back EMF equal to how much? That means V minus IARA, is not. So back EMF in the DC shunt motor, that means EV equal to V minus IARA. So how much the supply voltage of the DC motor? That means 500 volt given to you. So 500 minus IA equal to, you already find here often the value of IA equal to 97.5 ampere. So just put here 97.5 into armature resistance, that is equal to 0.2. Okay, so that is equal to 480.5 volt. This is your back EMF induced in the DC shunt motor. Okay, now EMF coefficient or torque coefficient, as we know that back EMF EB is directly proportional to the some constant into speed. Okay, k phi omega. So phi is also constant for the DC shunt motor or DC shunt machine. We can say that DC shunt machine phi field flux is also constant. So that can be included in the machine constant, that is represented by K. Okay, that is K equal to nothing but Pz by 2 pi A. Okay, so K into phi is represented by another constant, that is represented by C here. So EB by omega equal to C. You know, just put here the value of EB, whatever you find here, that means 480.5 volt. So just put in this equation the value of EB equal to 480.5 divided by omega equal to 62.83 radian per second. So this EMF coefficient is nothing but 7.65 volt. Okay, Newton meter per ampere. Okay, so more, what is the electromagnetic torque equation in the DC machine? Know that? What is the torque equation in the DC machine? That is motor electromagnetic torque, that is rated current. We can say that torque equation is K phi IA. Okay, so phi is constant for the DC shunt machine. So we can represent the K and phi with another constant, that means represented by C. So electromagnetic torque equal to C into IL. Okay, just put here the value of EMF coefficient, that means 7.65, and the value of armature current, that is 97.5 ampere. Okay, 97.5 ampere. So this one is your electromagnetic torque developed in the motor at the rated current, that is 745.9 Newton meter. Okay. So what is the nominal shaft torque of the motor? That means shaft torque or output torque can be represented as power by speed. Okay, so output power divided by the speed in radian per second. So put here the value of output power, that is nothing but 45 in kilowatt. So just convert this kilowatt in watt. Okay, so just multiply by 10 to the power 3. So power equal to 45 into 10 to the power 3 divided by omega equal to, that is 62.83. But if you simplify this equation, then you will get the value of shaft torque equal to how much 716.2 Newton meter. Okay. Now we want to the no load torque. Okay. So what is the no load torque at the no load condition? That means no load torque equal to electromagnetic torque developed in the motor at the rated current and subtract the shaft torque of the motor, that means output torque of the motor T0. Okay, then we can obtain the no load torque. Okay, that is nothing but T dash can be represented for the no load torque equal to electromagnetic torque developed in the motor minus shaft torque of the motor. Okay, that is called the no load torque. Okay, so we put here the value of electromagnetic torque developed at the rated current, that is how much? That means 745.9 Newton meter, and minus shaft torque or output torque, that is we already obtained here 716.2 Newton meter. Okay. So if you subtract from 745, then you will get almost the value of 29.7. Okay. So electromagnetic torque equal to the rated value, that means electromagnetic torque plus no load torque. So electromagnetic torque equal to the rated value torque, that means electromagnetic torque is equal to how much? 745.9 plus 29. Okay. So from this equation, you can just find out the value of this one. Okay. Regenerative braking. First case is regenerative braking. So a speed can be converted into a revolution per minute in radian per second. That can be converted in equal to how much? 60 omega by 2 pi. Okay. Just put here the value of omega. We already derived in the theoretical class or previous class. That is omega in terms of torque. Okay. In terms of torque. So this one back EMF equal to just put here the braking torque. This is braking torque. A is equal to how much? This value, that means 775.6 Newton meter. Okay, so just put this value at this place, and you already find the EMF coefficient, that means C equal to how much? 7.65 volt. So just put here 7.65 volt, and V is given to you 500 volt. Okay, and armature resistance is 0.2. So just simplify this equation. Yeah. So for the regenerative braking, speed equal to in the revolution per minute. That means converted. So 60 by 2 pi into 500 by 7.65 plus back EMF. That means 775 into 0.2 divided by 7.65 whole square. That means E square. Okay. So for the regenerative braking, your speed is 600 rpm, 650 rpm. Okay. What will be case for the plugging braking? Okay. So just to find out the plugging current, that means plugging current equal to plugging torque divided by constant term. Okay. So the torque is some constant into current. Yeah. So plugging braking current just we find out here. That means plugging current 775.6 divided by EMF constant C equal to 7.65. So if you solve this equation, you will get almost a plugging current 101.4 ampere. Okay. And just total resistance in the case of plugging, that means external resistance. Okay, so Jiaul, sorry.
Yes, sir. Good afternoon, sir.
Good afternoon. I think are you present in the previous class also? Is it not?
Yes.
Okay. In the previous class, we were discussed some numerical problem on the regenerative braking and plug-in braking and dynamic braking. Nah. So I think we already solved some part of that problem. So have you completed that one or just try to explain that? We already find torque value in the previous class. Okay. So just today find the speed for the regenerative braking and plug-in braking and for the dynamic braking. टॉर्क इक्वेशन तक तो हम लोग कर लिए थे ना पिछले क्लास में.
पिछले क्लास सर ज्वाइन नहीं किए थे सर.
Okay, okay, fine. So I think are you familiar with the DC machine torque and EMF equation?
Yes, yes.
Okay, so I think you have not too much problem because we only just basic equation of the DC machine we here use. That means one how we can represent the speed in terms of voltage and torque. Okay, that is the main purpose. So just speed can be represented for the DC shunt motor in this form. Okay. V by some constant plus back braking torque, that means TV into RA by C square. So इसको just simply जैसे EMF इक्वेशन इक्वल टू क्या लिखते हैं, बैक EMF इक्वल टू यदि डीसी मशीन में लिखते हैं हम लोग सीधे E इक्वल टू V प्लस IARA. नहीं, VT सप्लाई वोल्टेज इक्वल टू बैक EMF प्लस IARA. ओके, तो इसमें कितना हो जाएगा, V E माइनस V IARA इक्वल टू VT. यहाँ पे ब्रेकिंग के लिए अप्लाई कर रहे हैं तो करंट का डायरेक्शन उल्टा हो जाएगा, तो हम लोग टॉर्क का वैल्यू भी उल्टा एज्यूम कर रहे हैं, जो टॉर्क डेवलप कर रहे हैं, सो माइनस माइनस क्या हो जाएगा, प्लस हो जाएगा. ओके, सो दिस इज द इक्वेशन फॉर द स्पीड इन टर्म्स ऑफ वोल्टेज एंड टॉर्क. ओके, सो जस्ट पुट हियर द वैल्यू ऑफ voltage and torque what we will drive in the previous class. Okay, so in the plugging braking we just add the some external resistance in the armature circuit. Okay, so we just concerned about the plugging braking. Okay, here the
Okay.
total resistance armature resistance given to is 0.2. Okay, but when we apply the plugging braking we add the external resistance with the armature circuit, that is 5.5. So total resistance value in the armature circuit equal to RA plus external resistance, that is during the plugging braking. Okay, so this value equal to how much, 0.2 plus 5.5. Okay, that means 5.7. And just put here on the equation of speed in terms of this one. Okay, so if you put here the plugging braking current, that means 100 to 1.4 into total resistance. Total resistance 5.7 and this value supply voltage equal to 500 volt, and just simplify this equation, then you find the speed in RPM. That means a 97.3 RPM. Okay, and in case of dynamic braking, so just dynamic braking external resistance is added in the 2.6 ohm. So total resistance 0.2 plus 2.6 equal to 2.8. Okay. Sorry. So in this way we can just solve some basic problem related to the speed and torque for the DC shunt motor when we apply the either regenerative braking, plugging braking or dynamic braking. Okay. So I think, is it clear to you? Yeah. Or
Yes, sir.
और इक्वेशन में कहीं कोई प्रॉब्लम है? हाँ बोलो.
नो सर. सर ये सेकंड इंटरनल सर कहाँ तक आएगा पोर्शन सर?
क्वेश्चन सेकंड इंटरनल कहाँ से रहेगा?
ऐसा
Just
कौन सा मॉड्यूल?
module 1 and 2, just I have module 1, whatever the introduction about the electric drives.
Yes, sir.
Okay, I have discussed the control method, classification of control method, and classification of electric drives. That means group electric drives. जो भी हम discuss किए उसमें module 1 में, individual drives, इसका advantage, disadvantage, classification of control scheme. Okay, तो तुम लोग के पास है बुक कोई है कि नहीं? इनके देखा है एप्लीकेशन, इधर को कोई बुक?
Yes, sir.
कोई बुक है या कैसे कर रहे हो तुम लोग स्टडी?
Yes, sir. बुक है सर, एक है PDF बुक है उसका, जीके दुबे का सर.
जेके दुबे का है ना?
Yes, sir.
ओके, तो जीके दुबे को भी फॉलो कर सकते हो। तो उसी में से जो इंट्रोडक्शन पहला वाला चैप्टर है क्लासिफिकेशन ऑफ इलेक्ट्रिक टाइप्स, एंड दूसरा कैरेक्टरिस्टिक ऑफ डीसी मशीन, जितना हम लोग स्टार्ट किए अभी तक, टाइप्स ऑफ।
Yes.
ओके, ऐसे में रहेगा
Okay, sir.
इंट्रोडक्शन एंड।
सर न्यूमेरिकल भी रहेगा?
हाँ, न्यूमेरिकल रहेगा। न्यूमेरिकल थोड़ा बहुत डिस्कस कर रहे हैं, तो जस्ट सिंपल फार्मूला बेस्ड पे रहेगा डीसी मशीन पे।
ओके सर.
ओके, ओनली डीसी मशीन पे ही बेस्ड रहेगा, न्यूमेरिकल बेस्ड जो भी रहेगा।
ओके सर.
टॉर्क इक्वेशन
सर.
और ईएमएफ इक्वेशन और just application of regenerative and plugging breaking. Okay, equation discuss कर
Sir, can you share sir PDF of this to which
रहे हैं।
you taught us?
Okay, I try to share it. Okay,
Okay.
ग्रुप में ही शेयर कर
Thank you,
रहे
sir.
हैं। ओके, ओके, फाइन। So this is for the dynamic braking. Okay, simply total resistance, armature resistance equal to this one. That means whatever the armature resistance 0.2 and external resistance added during the dynamic braking, that means 2.6. So total value 2.8. Okay, and just we next today want to discuss about the speed torque characteristic of the DC series motor. This is all about the DC shunt motor. Is it not? Whatever I have discussed up to this point is all about the DC shunt motor. Okay. Now we want to just continue a speed torque characteristic for the DC series motor. So I think you are familiar with the construction of the DC series motor, how they draw their typical circuit diagram for the DC series motor.
Yes, sir.
कैसे ड्रॉ करते हैं हम लोग सर्किट डीसी सीरीज मोटर का? Any basic difference between the shunt motor and DC series motor? What is the basic difference between the series motor and shunt motor? Have you observed
Sir,
any? Yeah, just tell me.
in series, sir, they are connected in series and shunt in parallel. Armatures.
Which are connected in series and which are in parallel? Which we are talking about parallel and series.
Yes, sir.
That means here consists of two coil. One is known as the armature winding, another is known as the
Yes, sir.
field winding. Is not?
Field winding, sir.
So in this shunt machine or shunt, either it may be generator or motor, that means the two coil, armature coil and field coil, are connected in parallel. Okay, that means in shunt or parallel, whatever you may want to say, same things, shunt and parallel. Okay, so field coil and armature coil are connected in parallel in DC shunt motor machine, and field coil and armature coil are connected in series. Okay, in the series machine. So what is the this is the main equation. Okay, the main difference between the series motor, we are talking about the motor, so series motor and shunt motor. Okay, so again just tell me the what is the voltage equation in the DC series motor? Voltage equation in DC series motor. क्या होगा, जितना सप्लाई वोल्टेज हम लोग दे रहे हैं वो क्या होगा, टोटल एम्पियर करेगा, बैक ईएमएफ जो प्रोड्यूस होगा प्लस आर्मेचर रेजिस्टेंस जो ड्रॉप होगा, आर्मेचर रेजिस्टेंस जो ड्रॉप होगा सर्किट में। सप्लाई वोल्टेज इज इक्वल टू EMF induced in the motor plus IA R drop। तो IA R drop दैट मींस वही यहाँ पे लिखे हम लोग, बैक EMF इक्वल टू क्या लिख सकते हैं, K फाइव। तो डायरेक्टली यहाँ पे एक हम लोग लिख दे रहे हैं, दैट मींस बैक EMF इक्वल टू EB इक्वल टू V minus IA armature current into R। R is your total resistance, that means armature resistance as well as the field winding resistance, because field winding and armature winding are connected in series, so this is R is your equivalent resistance of the circuit। okay, but DC शंट मोटर में क्या होता था, इसकी जगह पे रेजिस्टेंस की जगह पे सिर्फ आर्मेचर रेजिस्टेंस होता था, नहीं?
Yes, sir.
So this
Armature is
is आर्मेचर रेजिस्टेंस। ओके, सिंपल है कि वोल्टेज जो हम लोग अप्लाई कर रहे हैं डीसी सीरीज मोटर में वो क्या होगा, आर्मेचर रेजिस्टेंस ड्रॉप प्लस ईएमएफ इंड्यूस्ड। सो इस इक्वेशन को इधर कर सकते हैं, तो वही चीज होगी। और स्पीड हम लोग को फाइंड आउट करना इन टर्म्स ऑफ टॉर्क, तो जस्ट ओमेगा इक्वल टू हम लोग क्या किए, इसको सिंप्लीफाई कर दिए, वी माइनस आई ए आर डिवाइडेड बाय के फाइव। ओके, so R is the total resistance in the armature circuit, that means RA plus field winding resistance। okay, so just we can say that for the torque similarly, motor torque can be expressed as the K phi IA। okay, तो यहाँ पे क्या होगा कि इन सीरीज मोटर जो आर्मेचर करंट फ्लो कर रहा है वही फील्ड वाइंडिंग करंट फ्लो कर रहा है, क्योंकि दोनों वाइंडिंग आर कनेक्टेड इन सीरीज। ओके, armature current and field winding are both connected in series motor, so flux depends on the field current is nothing but here in the series motor is armature current, so we can say that the flux is directly proportional to the armature current। बोल सकते हैं कि नहीं हम लोग, ये ध्यान में रखना, according to the connection of the field winding and armature winding। okay, we consider in the shunt machine flux is constant। okay, but here since the both series winding and armature field winding and armature winding are connected in series, so whatever the armature current to flow, that is we can say that the field winding में भी वही current flow करेगा, is it not? चूंकि दोनों रेजिस्टेंस सीरीज में कनेक्टेड एक ही पाथ में है तो एक ही करंट फ्लो करेगा। यदि दो रेजिस्टेंस पैरेलल में है तो क्या होता है, करंट डिफरेंस हो जाता था, एक में कुछ जाएगा एक में कुछ जाएगा, रेजिस्टेंस के कम, जिसमें रेजिस्टेंस कम रहेगा उसमें ज्यादा करंट जाएगा, जिसमें रेजिस्टेंस ज्यादा रहता है उसमें कम करंट जाता है। ये तो बेसिक प्रॉपर्टी है रेजिस्टेंस का, नहीं? सो टॉर्क इज इक्वल टू के फाई आई ए। ओके, सो फाई डिपेंड्स अपॉन द आर्मेचर करंट, ठीक है? तो यहाँ पे हम लोग क्या लिख सकते हैं टॉर्क इक्वेशन को, some constant into IA into IA, क्या हो जाएगा टॉर्क IA स्क्वायर, कांस्टेंट into IA स्क्वायर, नहीं, some constant into IA स्क्वायर। तो IA इक्वल टू कितना हो जाएगा, यहाँ से IA का वैल्यू फाइंड आउट करके यहाँ पे हम लोग को पुट करना है स्पीड के इक्वेशन, जस्ट वी वांट टू पुट इन स्पीड इक्वेशन, कितना हो जाएगा, आर्मेचर करंट इक्वल टू कितना लिख सकते हैं, ये बोल रहा है टोटल एक्सप्लेन कर दिए, कितना लिख सकते, आई इंटू आई स्क्वायर हो जाएगा ना, टॉप इक्वल टू, यदि फाई इक्वल टू फ्लक्स इज डायरेक्टली प्रोपोर्शनल टू द आर्मेचर करंट, तो क्या लिखेंगे सम कांस्टेंट इनटू आईए, तो आईए इनटू आईए स्क्वायर हो जाएगा। वी कैन से दैट द आई टॉर्क इज डायरेक्टली प्रोपोर्शनल टू द स्क्वायर ऑफ द आर्मेचर करंट, कांस्टेंट इनटू स्क्वायर ऑफ द आर्मेचर करंट। तो आईए यदि यहाँ से फाइंड आउट करना चाहें तो कितना हो जाएगा, स्क्वायर रूट ऑफ टॉर्क डिवाइडेड बाय दिस कांस्टेंट, we will represent as the k into k1 by the some new constant। okay, so K into K1 may be represent as the some new constant. ये आर्मेचर करंट का वैल्यू उसमें पुट करो, आर्मेचर करंट का वैल्यू उसमें पुट करो तो पुट किया। So this is your magnetization curve for the DC series motor. Okay, that is यहाँ पे magnetization curve क्या होता है? What is the magnetization curve? Field current versus field flux का graph. Okay, field current that means IF. Okay, so IF versus IA. But in series motor IF equal to कितना है? IA. किसमें करंट फ्लो कर रहा है? आर्मेचर करंट. Okay, so this is known as the magnetization curve. That means whenever you increase the armature current, okay, then flux will be correspondingly increased in linearity. Okay, this is directly proportional to the flux. So whenever you increase the armature current, your flux value is also linearly increased. So this is the variation of magnetization curve for the DC series motor. Okay. तो तुम लोग करेक्टरिस्टिक तो पढ़ा होगा ना, डीसी सीरीज मोटर, डीसी शंट मोटर का इस मशीन में. So that is the magnetization characteristic of the DC series motor. Field current versus armature current. Since the series motor field current is equal to armature current, so we can show here the armature current versus field current, field flux. Okay. ये वैल्यू क्या करना है, आईए को यहाँ पे पुट करना है, स्पीड के टॉर्क का इक्वेशन हम लोग को फॉर्म में फाइंड आउट करना है. दैट मींस यहाँ पे तो ओमेगा कैन बी एक्सप्रेस इन द टर्म्स ऑफ टॉर्क. जस्ट यहाँ पे पुट करो, जस्ट यू पुट द वैल्यू ऑफ, सॉल्व कर रहे हो जस्ट आईए इक्वल टू स्क्वायर रूट ऑफ कितना हो जाएगा, टी बाय के इंटू के वन. इसको हम लोग कितना लिख सकते हैं, v बाय के फाइव फर्स्ट टर्म. इसको कितना लिख सकते हैं, माइनस आई ए आर डिवाइडेड बाय के फाइव. तो आई ए के जगह कितना लिख सकते हैं, स्क्वायर रूट ऑफ टी बाय के इंटू के वन. तो सिंप्लीफाई करो इसको. एंड फाइव इक्वल टू कितना हम लोग यहाँ पे कंसीडर करने के लिए बोल रहे हैं, के वन इंटू आई ए. जस्ट पुट किए थे पहले, पुट किया, सिंप्लीफाई करो इक्वेशन को. हेलो, हेलो, सिंप्लीफाई किया या नहीं. क्या कर रहे हो तुम, जस्ट सिंपल इक्वेशन को इसको पुट करो ना. फ्लक्स के जगह K1 IA पुट करो एंड आर्मेचर करंट के जगह स्क्वायर रूट ऑफ T बाय K इंटू K1 पुट करो. इसको जस्ट सिंप्लीफाई करो. नहीं हो रहा है क्या, राहुल? Raul, hello. हेलो, आवाज नहीं जा रही क्या? रितेश, आवाज जा रही है कि नहीं?
Yes, sir.
तो जस्ट इसको सॉल्व करो ना। इसको सॉल्व करने के लिए बोले थे, यहाँ पे वैल्यू पुट करने बोले थे, फाई इक्वल टू हाउ मच? फील्ड फ्लक्स इज डायरेक्टली प्रोपोर्शनल टू K1 into आर्मेचर करंट एंड टॉर्क आर्मेचर करंट इक्वल टू, यहाँ से यदि हम लोग फाइंड आउट करें तो कितना हो जाएगा? स्क्वायर रूट ऑफ T बाय K into K1। इसमें पुट करने के लिए बोल रहे थे, जस्ट इस इक्वेशन को सिंप्लीफाई करने बोल रहे थे। इसको लिख सकते हैं V बाय K फाई माइनस IA इंटू R बाय K फाई। फर्स्ट लाइन में पुट कर दो। नेक्स्ट क्या हो जाएगा? V बाय K इंटू फाई की जगह K1 इंटू IA माइनस IA की जगह कितना लिख सकते हैं? स्क्वायर रूट ऑफ T बाय K1 इंटू K, यहाँ पुट कर दिए, इंटू R डिवाइडेड बाय K इंटू K1 IA। कितना हो गया? Some constant, that means if V is supply voltage we consider as the constant value, that means V divided by the square root of torque into square root of K1 into K. Okay. So speed of the DC series motor equal to some constant into square root of torque minus some another constant value. Okay. That means in this form, so just we can draw their characteristic. Okay. So this is all about the derivation. Okay. That means V by K phi minus IA into R by K phi. So phi equal to K1 IA. Just put here. So V by K into K1 IA. So this is you can consider constant K into K1. Okay. And V is already constant for the supply voltage of the DC series motor. So this whole term is constant. Okay. And IA equal to a square root of T by K1 into K2. तो कितना बच जाएगा? ये यहाँ से कैंसिल आउट हो जाएगा, तो V by square root of K1 into K into 1 by root T. So constant term divided by square root, okay, of torque minus this one is your R, is your constant value, armature resistance plus field winding resistance. Okay. Armature winding resistance plus field winding resistance. Okay. So just we stop here, and in the next session just start within 1 minute. Okay. So just rejoin again. I have sent to you link. So can we stop here?
Yes, sir.
Okay, and then again rejoin.
Okay.